Today we're diving deep, I mean really deep, into one of Earth's most fascinating and active underwater volcanoes, the Axial Seamount. For all you science enthusiasts, budding geologists, and curious minds out there, this is a topic you won't want to miss. We're talking about a colossal underwater mountain that's showing some intriguing signs, hinting at a potential eruption this very year. Now you might be thinking, an underwater volcano? What's the big deal? Well, the Axial Seamount isn't just any volcano. It's located about 300 miles off the coast of Oregon, sitting right on the Juan de Fuca Ridge, which is a key part of the Pacific Ocean's vast mid-ocean ridge system. This is where new oceanic crust is constantly being formed as tectonic plates pull apart. Imagine Earth's seams being stretched and molten rock bubbling up to fill the gaps. That's essentially what's happening at these ridges, and Axial is a prime example. What makes Axial so special, and why are scientists keeping such a close eye on it? For starters, it's one of the most intensely studied underwater volcanoes on the planet. It's been erupting pretty regularly, on average every 10 to 15 years. We've seen significant eruptions in 1998, 2011, and 2015. This predictable pattern makes it a living laboratory for understanding submarine volcanism. Researchers have deployed an incredible network of instruments on and around the seamount, creating what's essentially an underwater observatory. These instruments are like the volcano's personal health monitors. We're talking about ocean bottom seismometers that listen for quakes, tiltmeters that measure how the seafloor deforms, and even sophisticated sensors that detect changes in water temperature and chemistry. It's an elaborate setup that allows scientists to watch the volcano breathe, expand, and contract in real time. This level of continuous high-resolution monitoring is revolutionary for deep-sea research. So, what are these signs pointing to a potential eruption this year? It primarily comes down to seafloor deformation. Think of the volcano as a giant balloon. When magma, molten rock, starts to accumulate beneath the surface, it inflates the volcano, causing the seafloor to swell upwards. Conversely, when an eruption occurs, the magma chamber empties and the seafloor subsides. Scientists at institutions like Oregon State University and NOAA have been observing significant inflation at Axial Seamount. Data from tiltmeters show that since its last eruption in 2015, the caldera, which is the large basin at the summit of the volcano, has been steadily inflating. It's risen by more than 8 feet since that last event. This kind of uplift is a strong indicator that magma is refilling the reservoir beneath the volcano, building pressure for the next big event. To put it into perspective, this current inflation rate is faster than what was observed before the 2011 and 2015 eruptions. It's like the volcano is taking a deeper breath this time. While inflation is a primary indicator, scientists also look for increased seismic activity, more frequent and intense earthquakes, which often precede eruptions. These quakes happen as the rising magma cracks the surrounding rock. However, it's important to note that the exact timing of an eruption is incredibly complex and still cannot be predicted with absolute certainty. We're talking about a very dynamic system. The potential for an eruption at Axial Seamount isn't just a fascinating geological event. It has significant implications for various fields. For oceanographers and marine biologists, these eruptions create entirely new habitats. When lava flows out, it cools rapidly, forming pillow basalts and creating new seafloor. Hydrothermal vents, which are essentially hot springs on the seafloor, are often reactivated or new ones formed, spewing out mineral-rich fluids. These vents support unique ecosystems teeming with exotic life forms that thrive without sunlight, relying instead on chemosynthesis. We're talking about giant tube worms, specialized shrimp, and microbial communities that are truly alien compared to surface life. For climate scientists, understanding deep-sea volcanism helps us better model the Earth's heat budget and the cycling of elements through our oceans. The gases released during eruptions, though often less directly impactful on the atmosphere than land-based volcanoes, contribute to our overall understanding of Earth's outgassing processes. And for geophysicists, Axial is a natural laboratory for refining eruption forecasting models, which could eventually help us better understand and predict volcanic activity in other, less monitored areas, both underwater and on land. It's also a powerful reminder of how interconnected and dynamic our planet is. These deep-sea events, hidden from our direct view, play a crucial role in shaping the Earth's crust and sustaining unique forms of life. The data collected from Axial Seamount helps us understand not just this one volcano, but the fundamental processes that drive plate tectonics and the formation of our planet. So, while we don't have an exact countdown clock, the scientific community is actively monitoring Axial Seamount, ready to learn more about our planet's incredible forces. It's a thrilling time for deep-sea science, and every piece of data brings us closer to unraveling Earth's mysteries. What do you think about the possibility of another eruption at Axial? Have you heard of deep-sea observatories before? Let me know your thoughts in the comments below. Don't forget to like this video, share it with your friends, and subscribe to the channel for more fascinating insights into the world around us. Your support helps us keep exploring these incredible topics. Thanks for watching, and I'll catch you in the next one.